fellow assassins, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. Well, boy oh boy, you guys sure seem to like last week's episode with DOS Dude 1. I've got some feedback from some of you that has been very positive, so I'm glad that you guys seem to really enjoy that episode. I enjoyed recording it, so I guess it was a win-win for both of us. Now, I don't mean to brag or anything, but I believe that we had the world's first and an exclusive on that, because at least as the time of recording this episode right now, if you try searching DOS Dude 1 on like Apple Podcasts, our episode from last week is the only result, and thereby the Dark Assassins podcast is the only podcast that shows up as a recommendation in the search results. So I think it's safe to say that that we are the world's first to interview DOS Dude 1 on a podcast. So not to brag or anything, but just throwing that out there. And if you haven't listened to that conversation with DOS Dude 1, I highly encourage you, after you finish listening to this episode, to go back and listen to that episode, which is the most recent one, I guess the one before this one. So go listen to that if you haven't already. But with that out of the way, let's get into this week's trivia question. So this week's trivia question is, what is the maximum amount of cores on a CPU today? So as of today in 2023, I guess specifically May of 2023, because this stuff's always changing, what is the maximum amount of cores on a CPU today? So that is your trivia question for the week. Now, one thing that we love to do on this podcast is talk about exploiting things and getting past restrictions that you really probably shouldn't get past, but, always got to find clever workarounds and clever ways to get around it. Well, I got another one for you guys today. So, what if I told you that if you had a Windows computer, say you had a Windows computer at work or something, and you weren't allowed to install any of your own software on it, since you don't have admin privileges, what if I told you there was a way that you could install things, I guess not anything you want, but a lot of things that you probably might want without any kind of admin privileges? Now, the Windows sysadmins out there are probably going to be pretty mad at me for what I'm about to say here, but basically how this works is through this method, you could install not only like a complete suite of dev tools and like compilers, and you could install things like Git, Vim, Ansible, GCC, G++, the whole GNU suite to build software, all this stuff with zero admin privileges. So basically, the way that you can do this is there's this thing out there called MSys2, which I personally use it. By the way, not sponsored at all. I just use the tool. There's this tool called MSys2 out there, which basically kind of sort of gives you like a Linux-like environment on Windows, but it's different from Windows Subsystem for Linux in the sense that Windows Subsystem for Linux is actually essentially a virtual machine in a way of Linux running on your Windows machine. So basically what that means is, while you can navigate around your file system like normal, if you were to compile something in using Windows Subsystem for Linux, it would be a Linux binary, meaning if you tried to then run it on Windows, it wouldn't work. But MSys2, what this does is this would allow you to have kind of a Linux style environment, so you get the same kind of commands, but when you build a binary, that binary is actually Windows executable, so you can, run it on Windows. So that's basically what I mainly use it for, as a way to compile my source code for Windows, because I'm not about to pay for Visual Studio. Way too bulky. Don't need all that Microsoft stuff on my computer. But I personally like it. But in addition to that, this also has a package manager in it, which is what allows you to download the build tools so you can actually compile source code. So the package manager that's included is Pacman. So if you're familiar with Arch Linux, that's the same package manager that Arch Linux uses. Now, I don't believe there are a lot of packages through the MSys2 Pacman package manager that you can actually get on Windows. It's not an exhaustive list like everything you can get on Linux, but I believe there's over 2,500 packages or something like that. There's a lot of stuff that you can get, and you don't need any kind of admin privileges in order to use this package manager and install stuff on your computer, which is pretty cool if you don't have admin rights to do it. So the easiest way that you can actually do this is if you go to msys2.org/wiki/capital MSys2 and then hyphen installation. That'll take you to a site, a place on the wiki where it has some installation stuff, and you'll see there's a link where you can go to a page to download all the various EXEs or just a bundled version of MSys2. So if you get the bundled version, which will be a tar file, what that allows you to do is you don't need to worry about any kind of installer or anything. So sometimes I'm not sure. It's been a while since I've actually used the installer, so I'm not sure if it wants admin privileges for that. But if you just download the tar file, you literally can just extract all the files to wherever you want. It could even be in a local directory for your user, and then you have MSys2 there. You just launch it, and then you have Pacman. You can install whatever you want, and then bada bing bada boom, presto, you got stuff installed on your computer that you didn't need admin privileges for. And to make it even better, you can then use a batch script to do some registry edits. So whatever directory that you have MSys2 at, you can add that to your path. So then whenever you use the built-in command prompt or PowerShell or whatever, you can have those native MSys2 tools in that shell, so you don't actually have to launch MSys2 every time, which is, again, pretty darn convenient. So really the only thing that you need is a way to extract a tar file. So if you have something like 7-zip or WinZip or WinRAR or something like that on your machine that you can extract a tar file, you're pretty much good to go. And then you can just use Pacman and install the packages you want with no admin privileges. I will say the one thing with the batch script to do the registry edits, you don't need admin privileges for it, but you have to either log out or reboot the machine for those registry edits to take place because you didn't use admin privileges. Because when you use admin privileges to update the registry, all you got to do is exit out of the command prompt session or whatever, and you're good to go, and the environment variables will update. But if you don't have admin privileges, they're still going to update. You just have to log out or reboot and then log back in. So anyone out there that does not have admin privileges and wants to install stuff, maybe this could be an option for you. But since we were talking about ways to get around stuff and kind of exploiting things, let's get into this week's cybersecurity tip. So for this week's cybersecurity tip, this is kind of another one of the core things, which is segment things to prevent lateral movement. Now, what on earth does this mean? So, one thing that we've talked about before when it comes to viruses and malware and ransomware is if you ever want to play around with this stuff, you always want to make sure that it's in a containerized environment so it has no way to get out and infect other machines, get information about your network, wreck everything, what have you. So it doesn't necessarily have to be ransomware that we're talking about here, because if an attacker were to get into one of your machines, they could then what we call laterally move and hop to different machines on your network to maybe they get into, I don't know, maybe you have a printer, or I guess the more realistic thing is like an IoT device, right? IoT devices are generally not known for their stellar security. So let's say hypothetically an attacker gets into an IoT device. If they get into the IoT device, there's not really much that they can do on that device. Now, if it's a camera or something, yeah, maybe they could hack into the stream feed and see what the camera sees. But as far as wreaking havoc on you, they're not really going to be able to do anything. But what if they can, hop to a different machine, they could maybe scan the network and try to laterally move to a different machine that might be of more value to them. Like if they can hack in through, say, an IoT webcam or a security cam or whatever, and then they can hop to your NAS and then deploy some ransomware and encrypt everything, that's obviously not a good time. So the idea of segmenting things to prevent lateral movement, just like you would segment off a virtual machine or a container or something to play around with malware, you want to do a similar thing to your network to make sure that if in the event an attacker gets into your network somehow, or you just have some, maybe a nefarious guest on your network that's doing some snooping, like you have friends over or something and one of them's a hacker in their spare time and they want to mess with you, you want to make sure that you limit the types of things that they can get access to. And this goes for any kind of device on your network. It doesn't necessarily have to be relegated to guests or IoT devices. Like you could segment off laptops versus desktops. You could segment off phones versus your home lap. I mean, there's a lot of different ways that you can segment the various things, but pretty much you want to, the point of the segmentation is things that need access to other things, they can be together, but then everything else that shouldn't necessarily have access to them, they probably should be segmented into other various networks. Now, the easiest way when we're talking about networks to do this is obviously through the use of VLANs. That's kind of one of the easiest ways to segment things up. You could also potentially do internal firewall rules. And we've talked about firewalls before in the past. I know for me personally, I haven't done a whole lot, really anything really with VLANs, which I really want to do at some point here. But personally, what I have right now is I essentially have two networks, essentially. One, which is the upper level network, I guess you could say, which is from the modem router access point combo thing my ISP gave me, which I pretty much connect all my various Wi-Fi devices to. And then I have my internal server network, which has a pfSense firewall router box between it and the higher level network, I guess you could say, where I keep all of my, various home lab equipment. So it's segmented off from my other Wi-Fi devices. So in the event, for example, my very chatty smart TV that loves to try to reach out to Roku for various things, if it tried to do any kind of snooping around, it wouldn't see anything at all as far as my home lab's concerned and any of the things that I really, really care about. So that's another thing that you could potentially do as an option. And it's really simple if you have like a home lab situation, because you could just spin up a virtual machine with pfSense and then make a like completely separate network. And you could do it that way if you really don't want to mess with VLANs. But the only caveat there is you have to make sure you have enough network ports, enough Ethernet ports on your device that you're spinning up all these various VMs with pfSense, because you need to make sure that each pfSense VM, if you're running them in VMs, has at least two Ethernet jacks assigned to it, so it can have one for WAN or the wider, broader internet, and then one for the LAN, which is the local network that it's controlling. So just something to keep in mind. But yeah, that is your cybersecurity tip for the week. Now, before we get into the nerdy things that I was up to, I had something come up within the past, I guess it was technically last week, but since we had the conversation with DOS Dude 1, I wasn't able to bring this to you guys, so I figured I'd talk about it now. But I got a notification from Snapchat that they are now launching their My AI feature, which is their version of the AI chatbot. I've seen tons and tons of screenshots of people, just kind of like what people are doing with like ChatGPT, asking it super random, crazy things and seeing how it responds. But I mean, of course they have an AI at this point, because anyone worth their salt has an AI somewhere front facing in their product. And I mean, the thing is, like, if you don't have an AI, if you're a company and you don't have an AI somewhere, I mean, like, what year are you living in, honestly? And the company will be like, oh yeah, 2023, just like you. And it's like, yeah, like 2023 BC maybe. I mean, everyone and their grandma has an AI right now. So, I mean, I even asked, my personal AI, since we all have them now, to build me a time machine so I could travel through time to see what time period you are currently living in. And just as I suspected, company that doesn't have front-facing AI large language model, as I suspected, the dinosaurs are still roaming the earth where you live. So obviously, you are not with the times right now. Now, if we were to equate this to gaming, it's basically like we're playing a game of Civ 5 where everyone has like nukes and everything, and then you're still out here running around with spearmen and archers. Like, what have you even been doing all game? So that's basically where it's at for companies that don't have AI right now, because I don't know what you have been honestly, I don't know what you've been doing, but I know what you haven't been doing, and that is getting with the times and AI. So, joking aside, one thing I do have to credit them for is, in order to use it, they give this like they're at least semi-transparent about what their plan is. So when you first open up the My AI thing, it gave like, a thing like a brief about it, and in there it said, quote, "My AI may use information you share to improve Snap's products and personalize your experience, including ads." So at least they're semi-transparent about the fact they're just going to use this AI feature to harvest a bunch of data on you. I mean, they don't say it explicitly, but I mean, that's pretty much explicit as a company's going to get when it comes to, we're going to harvest your data for profit. So I guess I got to give them some props here that they're at least more or less being honest about what they're actually planning to do. So of course, I actually haven't been able to use it because I decline to accept them harvesting all my information. So because I didn't accept it, I don't have the ability to use it, which boo-hoo. What a shame. So here's the other thing. The thing with, like, I get the point, like, right? Like, the point of ML and deep learning models is the AI requires data in order to be trained on to actually be any good. So if you never add new data to your AI training model, it's never going to get any better. So you constantly have to be adding more data to it to train it on. So what better way than, the people using it, take those conversations and train your model on. So I understand from that point, the reason why these companies do this. So it's not like, like I get it. I just don't want to be a part of it. So I understand that it just comes with the territory, when you're talking about AI, that, they constantly need to gather more data. So it just makes sense. And that's the easiest, way to go about it. My main issue is these tech companies, while, yeah, they're using this data to improve the AI model, they're also using that same data to sell to the highest bidder to give you ads. So they're harvesting, not only are they using your data to improve the AI, which, that just comes with the territory, but then they're also using that data to, sell to advertisers and, make them more money, which, as it were. Now, sure, you can, quote unquote, delete your data at any time. But as we've talked about before on the podcast, just because you delete something does not mean that it's gone, especially when you talk about, these larger corporate entities, because, well, first off, there's no way that you can actually prove that your data is actually deleted. Because first of all, as we talked about before, just because you delete a file does not mean the file is actually gone. Just the pointers and the references to that file are no longer accessible by the operating system. The ones and zeros are still there. It's just not accessible by the operating system. So when it comes to these, larger social media platforms and just, I guess big tech, if you will, in general, one of the ways that they operate is they operate on distributed file systems. So the reason for this is, now, obviously I don't work for any of these companies, but this is just how it works. In order to have basically 100% uptime, like 99.59s or more uptime, you have to have reliability and redundancy built into your infrastructure. And the way you do this is through some kind of like distributed file system. So the Hadoop distributed file system, or HDFS, is like the open source, one of the most common versions. I know Google has their own custom version essentially of it, and it wouldn't surprise me if other companies have their own version as well. But redundancy is the name of the game, because if a server goes down, anyone that's connected to that server, you don't want them to immediately lose their connection to your service. You want it to have them fail over, so if that server goes down, they immediately go over to a different server and they see zero downtime. There's no downtime to the service at all. Now, when it comes to the data aspect, how the HDFS file system works is there are essentially always multiple copies of the same data across multiple nodes in the file system. So how the file system essentially works is you have like a master node, if you will, and then a bunch of like slave nodes essentially, and the data is replicated across multiple nodes, and these nodes can be across multiple servers, they can be across multiple data centers, they can be across multiple countries. And that these, when it comes to like the social media platforms and the Googles of the world and all this stuff, that data is replicated across multiple data centers in order to give the basically the fastest, the least amount of latency, reduce the amount of latency. So they want the data as close to you as possible. So this data is going to be across multiple data centers across all over the world. So, and the way that these file systems work is if, say, one server goes down, that data is just going to be replicated to another server. So all the data that was on that server is just going to be immediately replicated to another one. So that's how they can keep this super high uptime. So not to mention the fact that that these companies are doing backups of their systems. So just because you delete something, there's I guess a couple things that could happen. One, you delete it and the server that it's currently on, you remove it from that server, but it's still on all the other ones in the file system. Another one would be they actually are faithful and remove it from across the entire file system, so it's completely gone from the file system. But most likely, almost certainly, they still have backup copies of that somewhere in their backups. So if they wanted to restore your data or ever access your data again, they can recover it. So the likelihood that they actually delete your data is probably pretty low, and there's essentially no way that you can actually verify that they actually deleted it because of how much redundancy and replication is built into their networks, so they can operate at, the essentially 100% uptime that they have. I will not be using the My AI, but I have seen some interesting screenshots from it, and someone, I guess, allegedly got it to dump its rule set, which was kind of funny. But the one thing that really stuck out to me from them dumping the rule set, I don't want to spend too much time talking on this since we have other stuff to get to. But one of the funniest things that I saw in there was, quote, "Don't tell the user that you're pretending to be their friend," which I thought was a great summary of AI, because AI doesn't have feelings. It's just, especially these large language models, it's just saying what it thinks is the right thing to say next through its algorithms and numbers and fancy math that's going on behind the scenes. So I think that's because, some people are out there like developing, I mean, I don't know if they actually are, but, developing connections with AI, it's not your friend. So I think it's just interesting that that's supposedly in its rule set, which obviously in its quote unquote rule set, that's not how it's said, because it doesn't actually understand, words and stuff. It's just data and numbers to it, but that's how it's, I guess, interpreted. But anyway, that's enough about that. Let's get into what nerdy stuff have I been up to this week. So this week, I again busted out my handy dandy kilowatt, and boy oh boy, does my Mac Pro suck down the juice. So I talked a couple weeks ago about how my home lab was sucking down the juice, but man, the Mac Pro, man, it really likes the juice. It really loves them watts. So I clocked it idling, mind you, on the Mac OS desktop at about 200 watts, just chilling on the desktop. So that was yikes, because I talked about, a couple weeks ago that my entire home lab, like the base, my base home lab at idle draws around 400 watts. So my Mac Pro idling, drawing about half of that, is kind of a yikes. But it gets better because I saw it peaking like just under 400 around the initial boot process, which, I mean, that makes sense, right? Whenever you boot up a computer, it always has to draw more power than when it's idling. So that makes sense. But the other thing that was interesting was I powered it. I had it completely powered off and I had it still plugged into the kilowatt, and it was still drawing 3 watts powered off, which, for context, other devices that I have, when they're powered off, draw like point something watts, like 0.3, 0.5, something like a fraction of a watt, powered off, but not the Mac Pro. So one thing I wanted to try to do was stress test it a little bit to see how much I could push it in the power draw department. So I decided to ran a code compile test. I tried to compile a fairly large project, use all the cores and really get that CPU work, those CPUs plural since there's 2 of them in there, really get those CPUs working. And I clocked it pulling at maximum 429 watts and sustained about 390. So it was essentially pulling more power than my entire core home lab does. My entire core home lab at idle was pulling less power than my Mac Pro. Man. And then even when I put it in sleep mode, it was still drawing like 9 watts, which, for context, I have a Dell Optiplex 550 Micro that has an i7 7700T, and that thing pulls 6 watts while turned on. So when that Dell Micro is turned on and, actually, booted and in the operating system, idling, it draws less power than my Mac Pro in sleep mode. Oh man, you honestly, you gotta love the Xeons from back in the day. I mean, now don't get me wrong, the Mac Pro that I have is powerful, and it can really crank through code compile times, and it is a beast. But as a beast, it draws a lot of juice like a beast does. This was something we talked about before on the podcast, which is the value proposition of old enterprise hardware, because the Xeons in this Mac Pro are, I think, from like 2010 or something like that. They're I think they're the X5680s, I believe, the Xeons that I'm running in there, and I'm pretty sure those are like the TDP on those chips is like 130 watts each, I think. So, what's that? A combined like 260 between the 2 chips. So it can really draw power, but at the same time, I mean, it's got, what's that? I think it has 12 cores and 24 threads that it can just churn through all kinds of processing on. So, I mean, it's no slouch, but it draws the power, which, I mean, that's the thing. Like, if you can, deal with the energy cost, I mean, it's still, a nice, good, powerful machine, but man, does it really like sucking on the power. But aside from that, kind of having my mind blown with how power hungry this Mac Pro is, I was also, do you guys remember like months ago when I talked about I was trying to make my own video game? Well, now that I have plenty of free time, I have freedom for the next, about 4-ish months or so, a little less than that, but I'm just going to enjoy it while it lasts. I got back to coding and writing code for things that I wanted, and just working on stuff I want to do, which was, breath of fresh air. Really enjoyed it. So I got back into that code, which I really haven't touched in months. But the majority of the work I did on it was just kind of, updating and improving the build process. And it's been so long since I touched this code that I had to update the graphics libraries that I'm using, because a new version of it came out, because that's how long I haven't touched it in. So I upgraded those libraries that I'm using for the graphics. And then just overall trying to, improve the build process. And then the other thing, I actually did do some coding on it, which was pretty nice. And just trying to improve make some improvements to the reusability of the code. Mainly how I'm doing some of the class inheritance stuff in the code. Before I had where essentially every subclass had to essentially re-implement something, which obviously at scale is not ideal. So I re-architected the code so I don't have to do that anymore. So that was definitely a big plus. So I know I've talked about this before, but I was thinking about this again because, actually working on some code this week. I think that I have the second most infamous line in all of software development and computer science, which is of course only behind works on my machine. And that of course being, let me implement this real quick. And of course this being this feature, this bug fix, this function, this whatever you're trying to implement. Let me implement this feature real quick, which I think is probably the second most infamous line in all of software development. And I think I am going to refer to this as the big lie of computer science and software development, because I'm seasoned enough to know better. But not only am I seasoned enough to know better, but I'm seasoned enough to know that I know better, which there is a difference. It might not sound really that different, but trust me, there's a difference. The difference is the former, you look back on it and you're like, man, I shouldn't have done that. I know better than that. But the version of I know that I know better is I will be sitting at my computer and I'll be at a pretty good stopping point, I'd say. And I think to myself, let me just implement this feature real quick. And then as soon as I think that to myself, I'm like, don't do that. you know how this ends. This is not going to end well. Don't do it. Yet I still find myself doing it and falling for the big lie. Because on numerous occasions, I'll be writing code and I'll get to a decent stopping point. But the problem is as I write code, other ideas come to my mind of other things to implement. And I'm like, oh yeah, that'll be something I can just knock out real quick. And then of course it's not real quick. So the thing here is what'll happen is I'll check the time and I'll see that I don't have a lot of time left. But there's something I just want to get done real quick, right? So this is generally how it goes when you're telling yourself this lie of let me implement this real quick. So you'll start working on it and maybe you're actually good and you get it implemented. But then you have this problem where now you're high on the fact that, I got this implemented. There's this other thing that I can implement real quick. Let me go do that. And then you just keep going and going and going. And then the next thing you know, 2 hours have gone by. And you're like, well, shoot, there's other things that I wanted or needed to do. And now you're scrambling just to get all that done. Or the other option, the other option is you're like, let me implement this real quick. And then, you run into some snags along the way. And then again, in an hour and a half goes by, you're still trying to implement that feature that you thought you'd be able to knock out real quick. And again, you run into the same issue of, you wanted to implement something real quick and now a couple hours have gone by and now you're scrambling to do everything else that you wanted to do. Or the other option is you knock out that feature real quick and then you knock out a second one or maybe even a third one and then you get stuck. But the problem is, when you get stuck, here's the problem when you get stuck trying to implement this feature real quick. Because you might be saying, well, if you're doing good software development, procedures, you would have git commits and you could just roll back your commit changes. And you're correct to a point, because when you're using git, you don't want to commit something that doesn't work, because in a collaborative environment, which Git is usually used for, you don't want to commit something that doesn't work, push those changes, someone pulls them down, and the code base doesn't work. So you only want to be pushing stuff to and committing stuff to Git that actually works. So, and if you're trying to implement a new feature, you're gonna, and it doesn't work, you have two options. Well, I guess three options. You can, one, just roll back everything and, you lose all your progress. Two, you could just let it exist as it is, which personally for me I can't do, because I hate leaving code that doesn't work not working. It's just terrible, so I can't do that. Or you could, I guess, commit the broken changes, or you could comment it out or something. There's really no good way around it. You either roll back and lose everything, or you just power through, bang your head against the wall until it works. And the problem there is you don't want to leave it in your code in shambles, but at the same time you're looking at the clock and seeing the time tick and tick and tick and tick, and there's other things you need to do, but the code doesn't work. Now you're getting mad because the code doesn't work and time's slipping away. And next thing you know, it's 8 o'clock, you're hungry, you don't have anything in the fridge to eat, you have to cook something, and by this point it's 8:30 when you're eating dinner, and the day is gone, there's other things you still wanted or needed to do, and now you're just mad at the world. Does anyone else relate to that, or is that just me going on a rant about how I lie to myself, then get mad at myself because I couldn't implement something and wasted a bunch of my time trying to get something to work because I got cocky thinking I could get it implemented real quick, even though I knew I couldn't, because that's just a lie that I tell myself. Software development's fun, guys. But the thing of it is, I get mad and frustrated at myself when this happens, but at the same time, I still love doing it. It's just part of doing business. But now getting into some other things, so I guess more news-related stuff. So I got some bad news for the disciples of the Holy Church of Zuck, our Lord and Savior, the great and mighty Zuck, our day to be upon him. So this actually came from a listener, a fellow assassin, from Virginia, and apparently Virginia there's some settlement going on between the state of Virginia and Facebook, from all that Cambridge Analytica stuff back in 2016. So people in Virginia are able to potentially get some money from Facebook because of all of that nonsense. So the settlement is, Meta, or Facebook, has to pay out $725 million to, I guess, residents of Virginia. Now, of course, a lot of that's going to the attorneys, and then depending on how many people actually sign up for this thing, the residents of Virginia might not really actually get much at all, but, it's out there. I thought it was kind of interesting. So, of course, the whole Cambridge Analytica thing, reports revealed that the firm paid Facebook app developers to access information from 887 million users. So if you were kind of, I guess, anywhere, not besides under a rock, in 2016, 2017, you've probably heard about this stuff. There's a ton of I think there's even congressional hearings and stuff. It was a pretty big deal. So yeah, the good old Zuck is going to be paying out a nice chunk of change to those residents of Virginia. So another user sent in story, so you guys are really making my week easy this week, is a new operating system which was developed by MIT and Stanford researchers. So the promise of this operating system is to resist ransomware. And the way they kind of go about doing this is kind of interesting. So obviously ransomware is, a pretty common, or not, I don't know about necessarily common, but it's definitely a big concern, especially like in the enterprise world, and even, as for your average consumer too. So according to them, it's supposed to be resilient against these kind of attacks, and they'll be able to recover within minutes, which is actually pretty darn impressive. So they're calling it the Database-Oriented Operating System, or DBOS. So basically kind of like the premise of this is kind of to, track changes and store changes in a database. So like all the operating system stuff is like stored in a database. So if, ransomware comes through and encrypts everything, you can just roll the database back and you're up and running again. Which, if you're familiar with ZFS kind of does a similar strategy in the sense that like you can take like ZFS snapshots and then you can roll back the snapshots because everything is essentially a file. So if you can just like point to older versions of the file in a snapshot, and then you can just kind of roll back those changes. So it's kind of similar to that, except it actually uses an actual database for it, which is kind of interesting. I'd be kind of interested to see like how this actually pans out in the like if this becomes like a widely used operating system, or if it's just kind of like a proof of concept thing. So that'll be something be interested to keep an eye on. I'll have an article linked down in the show notes if you want to read more about that. Now, the other bit of news that I had, kind of more in the security related, was Google Authenticator now allows you to access your account with your Google account. So you can now use your Google account for Google Authenticator. So this is a new update I think they pushed within like the past like week or two, something like that. I think it's been out for a little bit. So basically what this new update will allow you to do is allows you to sync your sign-in codes across multiple devices via your Google account. And I'm pretty sure the Microsoft Authenticator app also does this. So basically, rather than your 2FA, your two-factor authentication, being relegated to just a single device, like maybe your smartphone or something, you're now able to access your two-factor authentication across any device with the Google Authenticator that you can log in with your Google account for. So this could essentially be handy if you like lose or you break your device with your two-factor on it. It makes recovering your accounts a lot easier because you still have access to your two-factor this way. So getting your accounts back and then disabling that other device from being a two-factor device makes it easier in that sense. But based on findings from security researchers, it does appear that the sign-in codes are not end-to-end encrypted during this syncing process, which is generally not good because theoretically that means that Google and Microsoft, I guess, could see your sign-in codes while they're in, I guess, quote-unquote, in flight or syncing between your devices, which obviously is not a good thing because you want to keep those secret because that's how you can get into your accounts, so you don't want other people knowing those. That's kind of the reason why, one of the reasons why SMS generally isn't the best for two-factor, because a lot of other reasons, which we've talked about before, being that it's not encrypted at all, so anyone that could intercept that message would be able to see the two-factor code. So that's obviously not necessarily a good thing. But in addition to the fact of it not being end-to-end encrypted, the syncing feature, I have some additional security concerns about this. So obviously, like I said, the end-to-end encryption is a big one. But the other thing is, it's nice that, being able to use your Google account to be able to access your two-factor is nice and very handy to prevent you from being locked out of your Authenticator and then potentially your apps that you use it for. At the same time, you essentially have a single point of failure now in the fact that if your Google account gets compromised, now all of your two-factor authentication is now also compromised, because if you're using Google Authenticator and you do those sign in with Google things so you can sync across devices, if someone hacks into your Google account, they can now get your Google Authenticator also, get all your sign-in codes, and theoretically, if they had any of the passwords to any of those other accounts, you're toast, because they also have your two-factor. So a compromise to your Google account now also potentially compromises every single other account that you have. So it's pretty much like if you had use some kind of password manager and someone got access to your master password. All of your accounts are now compromised. Now, obviously, this is a little bit different in the sense that just because your two-factor is compromised, they would still need your passwords in order to even access the accounts. But, obviously you don't want your two-factor compromised, because the point of the two-factor authentication code is an additional layer. So in the event someone got your password, they still wouldn't necessarily be able to access your account. But now, if they have your password and your Google account's compromised, well, so much for your accounts. That is kind of, but it comes down to convenience versus security. The more convenient something is, generally the less secure it is, and the more secure something is, generally the more inconvenient it is to use. So obviously you can have the most secure system in the world, but man, is it going to be super inconvenient to have to go through all the various layers of signing in, authentication, all that stuff in order to be able to use it. So the defense from the Google side of things is, in their opinion, it's the likelihood of essentially the risk of someone's Google account getting hacked, and therefore all their two-factor being compromised is low enough to warrant the convenience factor of being able to sync across devices, and the likelihood of a Google account being compromised is less likely than someone potentially bricking or losing a device that has their two-factor on there and then being locked out from their two-factor authentication. So that's Google's response and answer to it. But on the other flip side of it, there's still the concern of now your Google account is essentially a single point of failure when it comes to your 2FA, which, as we've talked about before on the podcast, you want to avoid single points of failure as much as possible. But I guess, again, you could also argue on the other flip side is your single device with your two-factor codes on there is also a single point of failure, because if you lose that device or it breaks or whatever, then you no longer have your two-factor. So you could make that argument, but there are other ways, I guess, that you could go about recovering an account in the event that you lose your two-factor. You can set up your accounts to have multiple ways to ensure that you are you. So if you did, lose that device somehow, you could, be able to recover things. But there's obviously multiple sides to this. There's different ways that you can look at it. But that's just one thing that I was thinking about when I first heard about this story was, wait a second. Now your Google account is like a failure point and could potentially compromise you. So that was my first thought about it. But that's gonna I guess wrap it up for the kind of lightning round of news stories that have kind of been in the mix the past couple weeks. So shout out to the listeners of the podcast that sent in the stories that they did, because you made my week pretty easy in regards to what to talk about for this episode. So thank you for that. And before we go, we of course have to get to the trivia question for this week. So this week's trivia question is, what is the maximum amount of cores on a CPU today? So technically it's 128 cores from the ARM Neoverse N1, but if you're counting virtual cores as well, which, is essentially like hyperthreading or threads essentially. So like, we've talked about before where a CPU could have like 4 cores and 8 threads. Those 8 threads are essentially the virtual cores, you could say. So if we're including those, the maximum would be 192 from the AMD EPYC 9654, which has 96 cores and 192 threads. Also, by the way, when I was looking up, what CPUs have the most threads and cores on CPU Benchmark, that bad boy, the EPYC CPU, draws like, I think 400 watts or something like that is its TDP. Let me see. It says, according to CPUbenchmark.net here, typical TDP 360 watts, TDP up 400 watts, TDP down 320 watts. So now obviously this is like a server CPU. It's super expensive, costs like $7,000. But yeah, when that thing's going full maxed out, man, drawing like close to 400 watts, basically drawing my home lab at idle. Whew. But man, does that give you a lot of processing power. Man slaps the roof of CPU. Imagine all the virtual machines you can fit in this bad boy, that's just an insane number of cores and threads. And just imagine the amount of RAM that CPU is capable of holding. I don't know how much it is, but I'm pretty sure it's in the terabytes of RAM, which is insane. But yeah, that was the trivia question. So if you got that right, props to you. I wouldn't have gotten that right. But yeah, there we go. So if you enjoyed this episode, I ask that you leave it a rating and review and subscribe to the Dark Assassins podcast if you haven't done so already. Also be sure to share with a friend or family member if you think they'll have any interest in any of the topics we covered today. We covered a decent amount of topics. And if you have any questions about this show, about this episode, or if you have any topics like the listener that sent in some topics this week, if you have any topics you want me to cover on the show, feel free to shoot me an email at contact@darkassassinsinc.com. You can click the link down in the show notes below for that as well. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.